Hello everyone. Now we are going to take a look at evaluating functions graphically. In this question, we have a piecewise function. We're asked to evaluate f of minus 2 first. So first of all, we should know when we have f of x equals something, then the x value is the input, and we find the input on the x-axis, and y value is the output, and we find output on the y-axis. So for f of 2, we know the input, negative 2 is the input, we don't know the output. We are going to go to the x-axis to find negative 2 first, and we go to our graph. When we hit the graph, we will go across to find the corresponding y value. So our output for f of minus 2 is 4. Similarly, find 0 on the x-axis. Here I am. Hit the graph. Here is the graph. And go to the y-axis. I am already on the y-axis. So f of 0 is also equal to 0. What about f of 1? Go to the x-axis, find 1 on the x-axis, and then you go to your graph. I should move up to go to the graph. When I move up, I hit the graph here at this point. This point is on the graph, and when I go across to the y-axis to find the output, it seems it is 1. What about the other one? When I keep going, there is one more point, but this point is empty, so it doesn't count. The empty points doesn't count, so we don't use empty points as outputs. f of 2, similarly, at 2 on the x-axis, when we go to the graph, this is an empty point. We don't count the empty point. It can't be an output. We should keep going. When I keep going to the up, I hit a point. It's filled, so I can go across to determine its y value, which is 3. Okay, this is what you do if input is given. We find the output. What if the output is given? In the last two questions, outputs are given, inputs are missing. So let's figure out what the inputs are. So f of x is equal to 1. So this time we go to the y-axis to find the 1. Go to the y-axis. Here I am. Here I had 1 on the y-axis. I should go to the graph. In order to go to the graph, I should go right and left, right? When I go to the right, I hit a point whose corresponding x value is 1. When I go to the left, I hit another point on the graph whose corresponding x value is negative 1. So I have two x values. My x values are negative 1 and 1. Lastly, I have f of x equals 3. Let's find 3 on the x-axis first. No, y-axis, sorry. Here I am. So when I go to the graph, I should go to the right and left. I have graph in either side. When I go to the left, I hit the point at this point in the graph. I should go down to find corresponding y-x value, which is negative 1 point something. That something is very close to negative 2. Let's say negative 1.8, for example. So x is negative 1.8. This is one of the x's. Another x, when I move to the right, I hit an empty point here, it doesn't count. Keep going to the right, I hit a lot of points. There are infinitely points here. I cannot count them. I cannot write them inside the curly bracket. When I go down for each point, my corresponding x values will be between 1 and 2, right? In this interval, I can find my x values. So how do you express the solution if there are infinitely many solutions? Here I have a method called interval notation. I'm going to use interval notation. Numbers from 1 to 2. 1 is excluded, 2 is included, because at 1 there's an empty point, at 2 there's a filled point. We will unite the others by using union. Am I done? I am not. I keep going to the right until I hit another point. I get 3. So negative 1.8 and 3, I can write them on the inside the curly bracket, and I have an interval. I unite them. So those are the x values that make function 3.